Welcome back to another Golang tutorial. We are going to go into some more detail about variables and data types. Having a strong understanding of data types and variables is essential when learning any programming language. Let's start with looking at declaring and initializing variables. Imagine you are moving and you have a box, and you want to use it to store some important items. A box is a container that can hold different things. Think of the items in the box as inventory. These items can be anything: books, toys, clothes, etc. In programming, we call the box a variable. A variable is like a named box in the computer's memory. It's a place where we can store data during the program's execution. The data we put inside the variable can be numbers, words, or other types of information that the program needs to do what it was designed to do. Before we can use a variable, it must be declared and possibly initialized. Declaring and initializing variables is the process of creating a named box to hold the data needed by the application. When you declare a variable, you give it a name and specify its data type, while initialization involves assigning an initial value to the variable. Now back to our box analogy. When I move, I tend to have a lot of boxes. So when packing, what I often do is write the name of the room where the items in the box belong. This makes unpacking easier. We can do something like that in programming. Let's say my application tracks the number of apples still in inventory. We currently have 10 apples. This code will first declare a variable called number of apples as an int and then initialize it to 10. Let's look at data types. Bear with me here. Let's go back to our moving analogy again. You have a box, but the box is made of paper. It's not going to be suitable to place every type of item in that box. Let's say you have an aquarium and you want to take the water with you. You can't just pour the water into the paper box. It would leak, so you would need to use a tank or a bucket. So boxes are only suitable to hold a certain type of item, and buckets can hold a different type of item. Let's try it a different way. If your box is very small and you want to put something big in it, well, you would need a bigger box, right? Okay, say your bucket and different size boxes could loosely be considered to be data types. Coming up with a real-world explanation of data types took me a little time, but let me know how I did in the comments below. So data types are categories of data in programming that define the kind or type of information that can be stored in a variable. They are used to ensure that the data is correctly interpreted and to perform appropriate operations on the data during program execution. For example, integers are used for whole numbers, strings for text, and booleans for true, false values, each serving specific purposes in handling and manipulating data. We already looked at the int data type earlier to store our number of apples. Let's look at a few more. Like in our moving analogy, we have different sizes of boxes to fit different sizes of items. We have the same option in programming. There are a number of different types of int, each with a different storage limit. The same goes for float and uint. Boolean allows us to store true and false facts. For example, if you have an employee system, you may want to know if someone is a manager or not. You could have an isManager variable and set it to true for the managers. Strings are used for storing text of any size, so things like our manager's name, address, or in some cases even a full document can be stored in a string. One of the things you may be thinking about is why we have different types of ints, uints, and floats. Well, each type allows for storage of a different size number. The bigger the number, the more memory it takes to store it. If you try to store a number that is too big into a smaller data type, Golang will detect an integer overflow and truncate the value to fit. Can you imagine the headaches this could cause in our applications? Imagine you deposit $5 million into your bank account and it's only designed to store 1 million? The remaining 4 million would disappear into the void. That wouldn't be good, would it? I can imagine a lot of really mad customers. You may be thinking now, why can't I just declare everything as int64 and ensure that it never happens? Smaller data types occupy less space in memory than larger ones. In resource-constrained environments, such as edge devices, IoT devices, or cloud servers where memory is limited, using smaller data types can significantly reduce the overall memory footprint of your application. This efficiency can lead to better performance, lower operational costs, and the ability to run the application on less powerful hardware. While you may be tempted to just use the int64 or float64 all the time, it's best to use the smallest data type you can, while still future-proofing your application. In the beginning, while you are learning, you may want to just stick with int and let golang figure it out. Working with constants. In our previous examples, we were able to initialize our variable with different amounts. You can change the value as your application runs, so if we sell an apple, then we can just set the new value of our apple variable to 9. Constants are fixed values that cannot be changed during program execution. They are used to represent unchanging or immutable data in a program, providing a way to give meaningful names to these values. A simple example of a constant would be pi, which is 3.14. This value is constant and will not change. Constants can be used for a number of things in your application. They can be used to store the location of files within your application, or a password to the database. These things will not change while the application is running, so we store them in a constant to prevent them from being accidentally changed. Type inference and explicit type declarations. As we have already seen, we can declare a variable of a specific data type in our application. It is useful to understand the different types of data you can store. However, sometimes the type of variable itself will only lend itself to a single data type. An age, for example, will only ever be an int unless we are talking about the age of the universe or something of that nature. An age is unlikely to be greater than what can be stored in an int, so there is no reason to use an int64. The Go compiler supports something called type inference, which gives it the ability to automatically determine the data type of a variable based on the value assigned to it. This means that you don't need to explicitly specify the type. The compiler figures it out for you. I can declare my age to be an int and assign 52 to it, but I could also just use the $= symbol to assign it directly, and the Go compiler will know that my age is in fact an int because 52 is an int. Want to test what you have learned? When learning a new skill, it's hard to know how to know if you have understood it correctly. So at the end of every lesson, I'm going to give you a short assignment. It should help you test to see if you have understood what we have talked about. The following video in the series will be me walking you through the assignment. So stay tuned for that. Anyway, here is your assignment. Write a program that calculates the area and perimeter of a rectangle given its length and width, using appropriate variable declarations and data types. Here is a hint. The formula to calculate area is length times width, and the formula to calculate a perimeter is 2 times length plus width. Or watch my next video where we will work through the problem together. Hope you enjoyed this video. Please remember to like and subscribe.